Have you ever stopped to think about what keeps you sitting in your chair right now instead of just floating off into space? Or what really makes a cricket ball rocket off the bat? Well, the answer is all around us. It's an invisible world of pushes and pulls that we call forces. They're the reason anything moves, stops, or changes at all. So let's dive in and explore them.
So just think about it for a second. Kicking a ball, pushing open a heavy door, or even just lifting your bag. I mean, they all seem like totally different things, right? But here's the secret. They're all connected by the exact same fundamental idea in physics, and that's what we're going to break down today.
All right, so let's start with the most important question of all. What exactly is a force? We use that word all the time, but what does it really mean, in the world of science? Believe it or not, at its very core, it's this simple. A force is just a push or a pull. That's it. Seriously, every single action, whether it's making something speed up, slow down, or even change its shape, it all comes down to a push or a pull.
And these two pictures show it perfectly. On the one side, you've got a classic push. The person is applying force to move the box away. And on the other side, the bullock is applying a pull to get that cart moving. See? Two different actions, but both are perfect examples of a force at work.
Now, this next part is absolutely crucial. A force isn't something an object just has, like its color. A force is an interaction. It only happens when at least two objects are involved. I mean, a football can't kick itself, can it? It needs a foot to interact with it for a force to happen. Take a look at this. That force that could get the car moving doesn't just appear out of thin air. It exists because the person in the car are interacting, his hands on the car's body. If there's no interaction, there's no force. It's a two-way street.
Okay, so we know a force is a push or a pull, and it happens when things interact. So the next question is, what could a force actually do? What kind of superpowers does it have?
Turns out, a force has a pretty impressive resume. It can get something moving from a complete standstill. It can stop something that's already moving. It can make things go faster or slower. It can change the direction of motion, and it can even change an object's actual shape. All of this happens when the forces are unbalanced. Let's see a couple of these in action. Here we go, perfect example. The cricket ball is heading in one direction and then bam! The force from that bat comes in and completely changes the ball's path, sending it flying off somewhere else entirely. That is an unbalanced force doing its thing.
And, it's not always about motion. Just look at this sponge. The force from the hand is squeezing it, deforming it, completely changing its shape. Now, if you let go, it'll probably pop right back. But that ability to change shape is another key power of force.
All right, this is where things start to get really cool. Scientists like to sort forces into two big teams. And it all comes down to a really simple question. Do you have to touch something to affect it? Or can you do it from a distance?
So on one team, you have contact forces. These are the obvious ones, right? Pushing a door, kicking a ball. You physically have to make contact for the force to happen. But on the other team, you have the more mysterious non-contact forces. These are the ones that can work their magic across empty space. When we think about contact forces, the first one that comes to mind is probably muscular force. That's just you using your own muscles to push or pull things. But there's another hero in this category, frictional force, or friction. It's the force that opposes motion. And trust me, without it, you literally could not walk.
So how does friction even work? Well, it's pretty wild. If you could zoom in on any surface with a super powerful microscope, even something that feels totally smooth, it would actually look like a mountain range of tiny peaks and valleys. Friction is just the force you get when those tiny imperfections on two surfaces snag and grind against each other. Okay, onto team non-contact. These are the forces that act at a distance. The action at a distance crew. The three big ones you need to know are magnetic force, electrostatic force, that's like static electricity, and of course the big boss of them all, gravitational force, the one keeping our feet on the ground.
And you've definitely felt this one before. When you play with magnets and you try to push two of the same ends together, you can feel that invisible wall pushing back, or how the other ends just leap towards each other. They do all that without ever touching. That's a non-contact force field in action. So, since we brought up gravity, we absolutely have to tackle one of the biggest mix-ups in all of physics. It's something that confuses just about everyone at first, the difference between mass and weight. So let me just ask you straight up, are they the same thing? The answer is a huge 100% no. They are not.
and understanding why they're different is a really big deal.
Okay, let's break this down. Mass is simply the amount of stuff an object is made of. We measure it in kilograms, and here's the key. Your mass is constant. It's the same on Earth, on the Moon, on Jupiter, anywhere. Now, weight is a totally different story. Weight is a force. It's the pull of gravity on your mass, and we measure it in newtons. And because gravity is different in different places, your weight actually changes depending on where you are.
And you can see this difference just by looking at the tools we use. To measure mass, we use a balance, which basically just compares your stuff to a known amount of stuff. But to measure weight, we use a spring scale, which actually measures the downward pull, the force of gravity. Different ideas, different tools.
All right, for our last big idea, let's solve a mystery that's fascinated people for thousands of years. How on earth does a giant ship made of tons and tons of steel just float on water? It seems like it shouldn't work, right? Well, the secret is a special kind of upward force. Here's the deal. Whenever you put an object into a fluid, and that means a liquid like water, or even a gas like air, the fluid pushes back on it. It gives it an upward push. We call this the buoyant force, or sometimes just upthrust. It's a force that's constantly fighting against gravity's downward pull.
So how strong is this upward push? Well, a brilliant thinker from ancient Greece named Archimedes figured it out. He realized that the upward buoyant force is exactly equal to the weight of the fluid that the object shoves out of the way. So if that upward push is stronger than the object's own weight, it floats. If the object is heavier, it sinks. It's as simple as that. It's even the same reason a hot air balloon floats in the sky.
So when you put it all together, you realize that forces are happening everywhere, all the time, controlling everything. I mean, as you're sitting there right now, the force of gravity is pulling you down, but the force from your chair is pushing right back up. Friction is stopping you from sliding away. The world is just this amazing, invisible dance of pushes and pulls. So take a look around. What other forces can you spot in action right now?